Hello, people. Hello, hello. Hello, hello. Hello, hello. Hello, myself. Um, just checking if everything is fine. And I guess we'll get started. Well, I'm so tired for some reason. Wait a second. Interesting. Yeah, okay, should be good. So... Let me just check a few things. We have this. Okay. I'm gonna close each. And... yeah, let's go. Let me increase the music a bit, the volume. Yeah, okay, should be fine. Okay, so the goal is for it to be a short stream. Wait, why am I there? Okay. Okay, good. Yeah, new light bulb too, as you can see. I changed the coloration a bit too. Maybe it's a bit too light. Tell me how it feels. But yeah, basically what I did since last time, well, since last night, I guess, is we have a torus. I put some colors on cubes like faces and stuff. Let me go outside of the torus. Yeah, here, for example. And as you can see, I also fixed the normal, and I also optimized a lot the destruction. Like there's no freeze anymore, which is impressive, actually. And basically what I did was, for the optimization for the destruction, what I did was just, when I built the mesh, now I'm storing the arrays directly here. And when I try to... wait. And when I try to raycast, actually, to destroy a block, I'm just looping through the triangles that have already been generated. So I'm preventing a lot of, you know, loops and all the cubes that are not rendered, all the triangles that are not rendered. I'm not doing I'm not applying the distortion again. I'm not checking whether the neighbor cube has a face on us. You know, I'm just like optimizing. Well, it's just optimizing a lot by nature, I guess. Ideally, well, I guess it's just this. I guess it's fine. I could put this one outside of the loop, actually. Okay, that's fine. Everything's good. So yeah, it's kind of optimized now. And as you can see, we have like a cube. And I also increased the size of the donut. Yeah, so for the normal, what I did was, I didn't know what to do much, so I just computed the normal again by using the cross product, because we know that faces well, they have like a certain direction to be rendered for the backface cutting. So this is, you know, I'm just using the cross product to compute the normal. And yeah, for the color, I just have an array of colors. I'm just getting the middle of the face, of the face, I guess, from the 4 vertices. I'm computing a hash from the coordinates of that middle point, so that, you know, it's random, basically. So I set the seed, and then I pick a random color from that seed, and then I add for each vertex of the quad, And here we go. So as you can see now, we have cubes that have different colors for each face, but that's fine. And right now we have, I mean, I guess you can see that there's something maybe a bit weird. Well, the donut is just giant, right? It's just really big. And can I solve that? I'm not really sure. Because to me it's like, oh, it's the first time actually. I just realized it's not about the cutting because we disabled the cutting, like the cutting here. But it's probably about the first time. So we have the camera, and we have the fall. So I'm just gonna, so it's like 4,000. But if we check here, I don't know actually. Oh. No, that's the chunk size. Oh yeah, we have this big radius, right? So I guess ideally I want to have everything inside. Okay, is it gonna lag? Okay. Okay, now we can see a lot more, as you can see. And it's like a donut, right? Well, this is just a radius though. What I want is the whole area. Plus maybe this. So that I can really see like everything. Okay? Let's pray. Okay, now we can see the whole donut, which is like really big. As you can see. Like especially if we have like this scale. And what I wanna do is I wanna distort this space maybe. Do I? Maybe I don't actually. But I guess I kind of do though. Because when I... Wait, is that up? Is that down? Oh wait, I'm locking the camera. Clamp. Let's clamp to this. Yep. But I didn't know you could. Wait. Oh, it's not scaling. That's fine. So, up. So here we go. We have this. And we can destroy, but if we go down, I mean, you know, we can still go down, but then there's this distortion, right? And what I want is, I want to remove this distortion. So it's gonna be kind of weird. Really. I don't actually know how to do that really well. But I actually have no idea how to do that. But we're gonna test some things, I guess. And see how it goes. So right now we have the vertex shader. And the goal is to do that in the vertex shader because it's gonna be like depending on the camera. So we don't want to regenerate chunks all the time. And what I wanna do is I don't want the... Do I want the donut? Maybe I kind of wanna... Do I have the camera position? I mean, I should have things related view matrix. And I can get the distance. Let me think. Okay, so maybe if I do... Okay, I can try something, maybe. I'm gonna have the... in view matrix, wait. Main camera... Yeah, in view matrix. Yeah. Too many cables. So XYZ, that's like the camera world buzz. Colors, position, buzz. Okay. So then what do we have? We have the position, right? And when I get the distortion, it's actually a bit tricky. I don't know. But wait, I have this though. Then I transform. Pick free. I guess I wanna undo the transformation to get into the referential, into the space of the space. So referential of like the blocks, I guess. Well, the chunks, yeah. And then I do something like +1. Well, I guess I can get like the current cube. I can do a +1, like to have like a step, and I can like apply a linear transformation. To undo things. Let me think a little. I think this is kind of what I want, but... it seems kind of complicated. Okay, can I first undo the transformation? Let me just think for a bit. Can I bypass this? I mean, I guess I can just compute it on like the CPU, send the information to the shader, and do the thing. I basically just want the current cube. I mean, I guess I can just do that on the CPU. Yeah, I mean, of course, yeah, I mean, I don't have to do that in the vertex shell. Yeah, that makes sense, never mind. Yeah, I'm just gonna do that on the CPU. So, I guess I can even do it like in GDScript, actually. So we have the space, maybe in the process. we should have I guess I still need like the inverse transform. So like we have get camera, like get worlds, get well, camera. I don't know. Could get camera. What was it? Viewport. My bad. Get camera 3D. Yeah, I guess it's from the camera, not the player. So. We have the global position. Apply batch. I don't have this. Keep tourist. This. And what I want is apply some stuff. Apply batch space inverse transform, maybe? Is it even like registered? It's a packed vector. So I could actually... Can I actually use it? Wait, can I... Because it's using co, right? Constant. Is it like as an argument of a function? I guess it kind of is. Is it? That's me. Oh, so we do have that. Update arrays and there's like this. Okay, so it seems to work. Probably. So that means bind methods. I don't have that. I should have it. So this, we have the cards. We have the same. Here. I mean, just have the actual functions. Okay. And now let's actually do something, well, what we want to do, right? So I want to first test if the inverse is correct. So for that, I'm going to go to the torus transform, space modifier. Yes, I had like this patch thing, but you know, I'm just computing the, well, I'm computing the normal from the cross product, so I don't need this. And the inverse of that. I mean, in any case, I guess we're just gonna get, well, the same variable. We're gonna have our little constants. And then we have this. So I mean, for each coordinate, that doesn't change. But what changes is like those things, right? Question is, how can I reverse all of that? I mean, actually, it's probably simpler than I thought. I guess we can start with dest z. I have r times cos u. So if I want to retrieve u, this is basically test z divided by r and r cos, right? So then I have u, and from u I can like do other things, I guess. But it seems still a bit complicated. So I guess I might be able to retrieve x from u, because the rest are like constants, so I can get x. Small radius. Oh, y is actually pretty simple too. So if we have x and y, then we just need z. R. Actually R. Wait, R is. Oh, it's changing depending on. Yeah, okay, no. You know what? Let me just ask Google. You know, let's be smart. Let's be fast. So. So is well. Wait a second. Okay. Wait, I'm just gonna. I'm just gonna copy. What? I'm not sure. I'm not sure. Wait, I'm a bit confused. So wait, y equals chord y divided by r times small radius. Let me just check. It doesn't seem to... Wait, oh, NV cubes, never mind. Oh yeah, never mind, okay, so it's there. So it's actually R times NV cubes divided by... Okay, it seems to be good on that point. You know what, we can just have this already actually, because I'm sure about this. We have basically the chords there, like this, is equal to R times NV cubes at Y divided by small radius, right? Then we have X. Do we? I guess we have Z first. We have Z. With Z, that is chord Z, so it's V times NV cubes dot Z divided by math tau. Let me check if they're doing the same. Z, V divided by tau times NV cube Z. Yeah, that's what I did. That's good. And I mean, X should be just, you know, we do the same. We have our equation. I mean, I kind of verifying at the same time right now, but I guess I'm doing the equations myself for this. So X it's a minus, so I do a plus on both sides. So I guess I get the thing there. It's minus, well, math tau. Oh wait, it's divided by... Oh wait, that's kind of complicated. Okay, let me just put this down. They have this. They have U minus this equal all of this. So now I want to times. I guess I want to divide by tau. So everything. And then I multiply by minus NV cubes dot x. Right. So at the end I have all of this, which is if we, what do we do? Times, I guess it's like NV cubes at x times, so we're going to change the sign. Math. Math tau minus u, we change the sign, divided by math tau. Okay, is it good? X equal tau minus u, that's what I have, divided by tau, okay, times NV cubes dot x. Okay, this is good, this is what I have. So now the goal is to find R and U and V, right? Because we actually don't have those. And to compute those, So U should be simple. Because we have, I mean, ACOS, the problem with ACOS is that there are like multiple solutions, right? Or there. Yeah, because, yeah, okay. Yeah, so that's why we have to use Atan, I guess. So basically we have our circle, right? Like this. If we have an angle, we can compute the cosinus for that angle. And there's like only one result, right? But if we do a cos, which basically the goal is to, from this value, the goal is to get the angle, then we have one possibility, but a second one too, right? So that's the problem with ACOS. So I guess with Atan 2 actually, we can specify things so that we are sure we get the right angle. Like Atan, we only have one double as an input, but Atan 2 has like two floats, so we can basically specify things to that. Which one is the correct one? So I guess I can't really use this line with like actually this line with the cost to get the U, compute the U. So what I'm gonna do is I'm gonna use, let me actually check again what 8 and 2 does specifically. Math. Okay. STD 8 and, yeah, I guess it's 8. Oh yeah, okay, I guess it's STD. So C++ STD 8 and 2. C++ reference until since what? Context since C++ 26. Oh, that's good. I'm glad we're adding more things to, well, as context preparations. Wait, we have SIMD in C++ 26 directly in like C++. Wait, that's crazy. That's good. Planes. Wait. They have SIMD in the standard data parallel types. Wait, that's crazy. Basic vec. Data parallel vector type. Wait, that's crazy. Oh, wait. Basic vec. Okay. It's just an alias. What the wait, what? Okay. Chunk. Algorithm. Clamp reduce. Permute. Well, functions are overloaded. So it's like directly there. Bit manipulation. ABI compatible. Well, ABI things, I guess. Compatibility. How does it look like? 1. Okay. This one is a lambda, I. Oh shit. Wait, what? That can take a lambda. Wait. A plus B. Wait, what? Wait, what? Because the lambda is not called, right? The print. Wait, what is B? -2, -1, 0, 1. Wait, how do you define the range though? How do you have the range? I don't. But yeah, this is like really good. I just don't get this. And it's like context too. Everything is just context. That's crazy. Auto const A. I guess it's like println. Okay, yeah, it's a custom function, so I guess it has to do with this. Kind of. So it's I. Wait, so it's I. And I can AI. What? What? That's crazy. One. Oh wait, so it's actually a size of 4. Oh right. Okay. I get it. I get it. A plus B, so we add the 2. Okay, I get it. Okay. So yeah, there. Okay. Okay, I get it. So yeah, there are only like 4 elements. So when I put a lambda there, it's actually initializing the 4 elements from I, so from 0, so it's starting at -2. Okay, I get it. So yeah, no, it's not like lazy evaluation or anything. I thought it was something like that. But okay, good. What about Aitan? The arctangent of y divided by x. So, what's the arctangent? How can I visualize that again? The range minus pi plus pi. Anyway. Hey! Oh, never mind, it's so bad. Okay, so let me just check again. I'm gonna try to understand. Because I'm not very good with like trigonometry functions like that. So we have R. I guess this is the first one. This R equals... Wait, what? I guess you can get V. I'm just checking a few things. Then we recover R. From U and sub. Okay. So What from V? Wait. Yeah, V seems like the simplest one. Actually. Yeah, okay, let's just do that. So, okay, basically, apparently, I guess I can just do this. Well, yeah, let's have two tests, I guess. You know, just to ensure that everything's good. Then we assign at the end. It's good. It can optimize that if necessary. It's a compiler. So, okay. So yeah, U is a tan 2 yx. Well, when I say that, it's like chord and chord, because originally we have this and we have, wait, it's V, it's not U. So yeah, we have this on the side. So stuff happens and wait a second. Oh, if we divide, oh, that's right. Oh, so okay, I get it, I understand. So basically, if you have this, you can divide the two equations. So you have this divided by this equal this side divided by this side, but then you can cancel because like these are the same, right? So then you just get this divided by this. And I guess that's it. I guess that's basically then you have well, it's like, I was gonna say it's a tan, like a tan cosine formula. Tan cosine. Let me. What was it again? No. Wait, there's a function I forgot. Arcsine. Arctan. What was it? Was it like the sinus law? Like sinus law, sine, cosine, tangent law. Law of sines. And law of cosines. Okay, yeah, so that's it. And law of tangents. Yeah, no. Yeah, but there's no like tan equals something. Tan. Yeah, this, right? I was gonna do that. Yeah, tan equal this, right? Yeah, okay. Okay. Yeah, I'm not crazy. So I guess you actually have to do the opposite. It's like this. Well, divided by this. So we get what is inverse, I guess you call it. So you have this. And I guess this is... this equal... So we just saw that it was tan of V. And now basically we want the... the A tan from this to cancel out and find V. And as you can see, A tan 2 A tan 2 is just the arctangent of y divided by x. So we basically get this. So that's why it's, you know, A tan here. Okay. So we find V. Good. Good. I suppose. What about the rest? So we need U and we need R, right? Let me look just a bit. So we have those. So now that we have U, can we actually get this one easily? Maybe not. Could get R. I mean, we have V, right? So that means we can compute cos V. That means we can divide. Right? Let me try something. So we have all of this. That means now we can actually divide. We have this divided by cos V equal this. And we have the same with y and sin, the sine. I mean, I guess we can remove this. So we can remove the big radius from this. Big radius. Okay. And now we can... I mean, I guess we can't really divide right away. Wait. So, I mean, I guess we have the two together. So we can't solve it like this. Can we? What if we do a plus? What if we do a minus? No. What if we do... Let me zoom in a bit for you. So yeah, we should use... maybe not. Wait. What was it? Here. Yeah, I guess we have R here. We also have U. So I guess we can try to combine things. So we get a tan again. I mean, I guess we can compute U actually from that. Because what if we divide like this by this? Then the R's cancel each other. We have sine divided by cos. We can convert that into A tan, like we did earlier. And we can find U. And from that we have U, we have V. So we can just compute R like with a single equation, right? With a single line. Let me check what we have. Do. So yeah, like on my side, it's trying to compute R first. Because I guess it's like only... Never mind. I mean, I guess, yeah, well, the way I was doing things, I would have had to have like a lot of sine and cosine, you know, divide by those. So that's why I'm looking. I'm just gonna try this. So I guess we have wait, oh, I guess we can see it from the tourist perspective. So what is R? R is the small radius. Oh. Okay, I get it. So basically we have the distance from the middle of the torus, which is gonna be math squared this plus this. Do I have like a squared? I don't. That's fine. So this is not really the, well. So the final coordinates. Okay. Wait a second. So okay, I think I get it. We have like a distance d. It's the distance of like the coordinates to the center of the torus, and it's basically the big radius minus or plus the small radius times sin, right? Sin u, I guess. Like it's just here, right? So this is basically d. Is it? I mean, yeah. And z equal this. Yeah, we know that. Okay, so I guess it was kind of going the way I was trying to go. Therefore, r equal the square root. Wait. Let me do r equal square root of d minus, wait, what? Okay, d minus big radius times d minus big radius plus chord z times chord z. So what we're trying to do is like it's Pythagoras, right? Just here. And then. So it's like in 2D. It's Pythagoras in 2D. So we have like all of this. And then we have the z coordinate. Oh, okay. Oh yeah, that makes sense. Does it? Yeah. And we basically Pythagoras. Okay. And then we just have u. I mean, for u, it's gonna be kind of the same as v. Because it is v, right? Anyway, 8 into d minus big radius z, let's say. Let's do that. I'm gonna think about it a bit more another time. For now, we should have the reverse. And like I take this, like this is correct, this is for sure, this is correct, this is for sure. The rest is a bit more, I would have to spend a bit more time on it, but yeah. Let me go to chunk space. And we have apply, maybe not, here. Apply batch transform. So this is here. And what I want is just apply the inverse now. And actually apply the inverse again, because I'm really bad. I'm really a bad person. And then apply this again to really ensure that this is correct. Okay. This is gonna be a lot of transformations, but that's fine, it's only like one time when I start the engine. So it should be fine. Okay. Okay. I'm thinking about vehicles and that kind of stuff, like collisions are going to be a bit complicated with like different spaces and all. I mean, I guess I have to, for collisions, I can just apply the inverse. Then I have to find the coordinates. I mean, never mind, it's fine. Yeah, it's fine. Yeah, it's like straightforward, it's like 01 after that. Kind of. Okay. I mean, basically it's gonna be discrete, that's the problem. Maybe I need like a solver, but if I have a solver, it's going to be really slow, I feel like. I'm not sure about this. Non-constant. What is this about? Okay. Bindings. From T to packed array. Okay, I guess I can remove this. A shame. Ah. Pack sphere to free array. I mean, maybe I just have to pass by copy because it's not a copy array. But then it wouldn't apply the modification. Would it? I don't know. Okay, linking. Yeah, I should maybe... I was thinking about like optimizing the compilation speed, but like I guess it recommended moving to like the extension, which I don't really want to do that. Or like maybe go in release. Like maybe allow for Visual Studio to do like something with like the linkage. So anyway, let's play. A lot of transformations are expected, and it should be just a square. Yeah. So it's good. And it's 300. Zero. Okay, so we have our chunk. What is this? I mean, I feel like there's a problem. Oh wait, am I inside the chunk? No. The sides have a problem. Oh, is it because backface cutting is... Oh. No, I mean even that wouldn't... It shouldn't do something like this. So maybe it's not working properly. Like, is it that I just shouldn't do that? I mean... Oh, wait! Oh, because I was thinking about it like matrices, right? Is it like commutative? Maybe it's not. Not commutative. Associative. Let's just try like this, I guess. So we should get what was the goal again? Yeah, to implement the inverse function, right? So after we have that, we implement it in the shader. And I don't know. Oh yeah, we do the +1, -1. And we basically have like we basically apply the transform on the units, on axes, yeah. And then we change the, like we can make a matrix from those axes, and we can multiply the view, like I guess not the view, but like the position of the vertices that we render by this matrix. So the goal is not to cancel the transformation. I mean, we could do that too. But if we cancel, that means we won't be able to see like the donut shape, right? I still want the player to see the donut shape. I just want the ground to feel flat around the player, and the cubes to feel like cubes without deformations. So it's like a bit different. It's like a specific kind of transformation. I hope it's gonna be fine. It's just something I thought about by myself. Yeah. Okay. Let's see how it goes, please. Yeah, it's okay. It's okay. Good news. It's kind of the same. Bad news is kind of the same. Oh. Okay, no, this is good. So good news is that the inverse, yeah, it's like an inverse, so we can just multiply. It's like the identity. We can, I mean, what I was doing before was working too, right? Because it's the same. Okay, the only problem is the radius. I actually have the wrong radius. Do I? Never mind, I don't. Because it's here. Yeah, I'm not doing anything in the shadow right now. So, okay, so this is wrong. The inverse is wrong. This is interesting. Okay, so I guess I'm gonna try this equation by myself. So I was sure about this. I wasn't sure about that. So I have to retrieve R and U, right? So we have this R and U. Wait, what? Yeah. And then we have this. I guess we have to start from this. Yeah, okay, yeah, we just have this. We just need this. So we have this. And what I was saying earlier was... Yeah, I'm probably gonna remove this. Wait, Z, I need Z. So we have this. Now I can do... I guess yeah, never mind, this is good. Scene and cuss. Yeah, this is good. So basically we have R equals test Z divided by cuss U. And we have... wait, if I divide, it's not... No, okay, the goal is to find U. The goal is to find U, so I can divide. So I have this. I'm gonna do the minus... wait a second. Sin V. So I guess I'm gonna divide first. Then we get this. Then I'm gonna do the minus. Okay. So these are constants, right? We have those values. Oh wait, I guess I can just divide by R then. Like this. So we have sin U. Oh wait, this is actually good. I guess we have divided by test Z. Wait, if I divide, isn't it supposed to be... No, that's fine. Okay, yeah, that's fine. Okay. So it's 1. And now I can actually multiply them, right? And if I do, it's going to be kind of like easy actually. Things are going to cancel each other. Kind of. So you have this. And we're going to have the times. Like kind of like this. The multiplication, the product. And this is going to be equal to sin U divided by cos U. And that means we can, you know, tan this. I forgot which one it was. That's a bit embarrassing. Which one was it? Tan equal cos divided by sin, like the inverse. Sin divided by cos, okay. So this is sin divided by cos. That means we have... this is tan. Wait. Wait, what? Wait a second. Sin tan of V. Yeah. Yeah, okay, yeah, this is good. So yeah, this is just tan of U. We can simplify on the other side. Like we have times R. And we divide by r afterwards, so we can just remove this. That means that this is just a division at the end. And that means we have 8 and 2. Wait. I mean, I guess it's fine. I was just wondering about the second value, because I'm gonna divide by z. I guess it's fine. I'm not sure about this, but maybe it is. So u equals 8 and 2 of this and this. Like, I guess it's 8 and of all of this. And we're gonna, you know, change it later, but yeah. Let me... V, how... I gotta clean this up. I have to clean this up. X and Y. Okay, so I might remove this. Yeah, probably first best. So we find V. Then we find U. So it's Y, so I can remove the X, I guess. Okay. So we have... Let U equals 8 tan of this. What is it, 2? And instead of test, it's gonna be chord. Floats. Right. Something like this. Okay. And the last thing is R, right? We want R. But that should be like trivial. R should be trivial. Because we already have all of this. I guess if we do ACOS, it might not be good. We only want to use tangents, and well, arc tangents to have the good values, probably. Maybe? So... it's actually a pain. I mean, I can try that for the fun, but it's not gonna be It's not gonna work, right? I have like very low expectations. And I don't really know about 8 and 2 here, actually. I feel like I cheated a little bit. Just like this, divided by cos. I can try that. Oh, I guess I only modified the CPP, so it should be fast, right? Maybe, maybe not. Let me think a bit about things. Yeah, okay. Please. My math, please be good. Okay, it's not flat. But it looks very similar to how it was the other way, too. And there are like a few nice things, like this is correct, but actually not all the way. Is it because it's wrapping or something? Big radius, small radius. Oh! Wait a second. Am I even using like small radius and stuff? I'm using the big radius, but what about the small one? Because R equal... I'm using it, okay, I'm using it here, so it should be good. V equal all of this, so Z equal V times cube Z divided by 2. Yeah. Now, Z is kind of the same, actually. Wait, no, I just... Wait. What? Yeah, so for Z, right? Z is V times cube Z divided by 2. That's what I just said. I just checked it, okay. This one is R, okay. So the R one. Oh, yeah, so it's actually just the same, but instead of toe, it's like small radius. Okay, works well. Yeah, this should be correct. So I'm not sure I get it. But I get what's wrong. I mean, it's probably the cost in a way. I mean, I know that V is probably right. But yeah. Okay, let me just check this again. Because I kind of did that by myself. And on the side, the overload kind of computed things and has the same actually. So z equal v divided by tau times nb cubed c. Yeah. And y is r. This is good. And x tau minus u divided by tau times nb cubed. Okay, so yeah, this is correct. This is definitely correct. This is definitely good. Destination is assigned correctly. This is false. Oh, wait. Oh, I forgot the ACOS, actually. Oh, okay, that's why it was weird. Okay, yeah, let's try again. It's probably gonna be a lot better now, actually. So let's pray. I mean, still ACOS, so I'm not sure, but yeah. And aside from that, is there a way to compute R without all of this? Well, without ACOS, maybe with ATAN. There should be a way. Okay, let's try. Is it flat? Please, be flat. What is this? Wait, there's no collision though. There's just this weird thing around. And this. It's kind of weird. But as well. There's still like a deformation. I mean, it's bad, it's just bad. Oh, wait. Wait a second. Let me show you something. Oh. I think it's like definitely the problem we have. One thing to watch out for. Basically, you know, like the circle is just like looping, right? But in our case, we have 0 that is like very defined. And like 2 pi, well, that is like at the end. But like 2 pi is like coming back to 0 actually, in our case. So we have like some problems related to that, right? So yeah. We need to wrap the resulting coordinates. Yeah, it's a bit tricky. Wait, so basically it's like this. 8 and... Yeah, there's just this one I didn't do. That is interesting. Okay, let's maybe try this time. So we have V. I'm gonna comment this for now. We have D, which is the square root of the point, the chord. Wait, no, it's not. Yeah, it is. Okay, Pythagoras. Then we have R. That is the square root of B minus big radius times this again. And we're just gonna do a plus. It's P and Z. So, well, Z basically here. I guess it's a dot product actually. Well, it's yeah, it's Pythagoras. Well, yeah, it's the square root of the dot product, which is the Pythagoras theorem in an Euclidean space. So, okay, let's say we have this. Let's say then we have U equal 8 and 2. Of D minus big radius theta Z. It's probably better because it doesn't even have like it doesn't have a ACOS or ASIN. So yeah. The coordinates, so we have this. And yeah, let's just add the check this time. Just in case. And I might have to do something a bit different. I mean, I guess it's kind of normal that it doesn't work well. I don't know. I was thinking maybe doing that. On the vertices was a mistake, but that, you know, there's no real alternative. Okay, so we have all of this. And I think there's just a huge plane. But is it just really small? Yeah, it's broken. I mean, actually, it's kind of like this, not the same as what I had, but very similar, right? But yeah, it's like still tilted. And it shouldn't be tilted. So I'm not sure I understand. Is there a way to... I mean, I could have like a hash map or something. This is bad. Bad idea. I just need the inverse. You know what? Google filters inverse. Parametric equation inverse. Because torus is wrapped around into circular dimensions. The mapping is technically 1-to-1. Okay. Oh, wait a second. That's why I have like problems in both ways. Like both ways are bad. Okay. What if I remove the last chunk or something? So this is for the full internet, right? So the inverse equations. I compute u, which is what I do. The poloidal angle v. Calculate the distance of the point. So I have the distance, I guess. Then use the z-coordinate and the projected distance to find v. But this one is a bit different. So v... I don't have... Oh yeah, so it's finding v directly. So I guess it's kind of what I wanted to do first. So it's like z and d minus r. What about r though? Wait a second. Yeah, what about the small r? I mean, I guess it's not even using it. That's crazy. It's not even used. It's probably better. I mean, not for the death. We need to account for the death, but yeah. Normalize if required. Yeah, let me just try this. Wait, you? Yes, you. Wait, what? Wait a second. So yeah, I guess it's like the opposite. I guess formulas are a bit different. Let me check what they have. In their case, they have r plus cos v times cos u. Okay, so u and v are the opposite. And we have cos here instead of sin. Oh. And we have sin here. Yeah, that's a way. That's one way to do things. That's fine. So have v change v and u, and this is sin. V Z D minus R. I still compute the distance. So math Atan 2 of Z and D minus big radius. Okay, I have like U and V, but I don't have like X, Y, and Z. Retrieve base coordinates. It's fine. Okay. So we have the angles. We should have the angles. But I guess it's just the angles though. Then we have this one. I mean, I guess it's good enough though. Yeah, okay, let's... Okay, let's just have something like this to y. Okay, that's fine. That's y equals car dot y. Car dot y? It's like the radius. That's not gonna be good. I'm just gonna go freestyle and vibe coding it, kind of. I'm just gonna have... okay. Math square of squared of x times x plus y times y, so it's chord. It's gonna be chord. And then we have minus big radius. And this is plus... wait, what? It's squared again? Wait, what? Makes sense, I guess? Not really. Okay. Then plus z times z. I guess that's one solution, apparently. It's not optimized, that's fine. Well, optimized as in I'm repeating stuff. Wait. In any case, there's going to be this distortion problem. I'm not sure how to fix it. Actually, there shouldn't be... Oh, no, never mind. There's gonna be problems. Because it's triangles directly. Grrr. I mean, I guess maybe it's fine. Yeah, it's fine. I'm never gonna use this function, right? I just said it before. Well, not... Well, I mean... Like, directly on the player's camera, right? This is why it's, like, looking really bad right now. Because it's not supposed to be used this way. I mean, it's... What is that? Interesting. So my idea was to... We have a lot of things, right? I'm gonna remove the last one. Let me actually move that to the side. What about the first one? Remove it? Yep. Oh. I'm abusing my power. There are some problems. I didn't think it would be like that complicated. Wait, did I actually restart the engine? I mean, I think I did, but let's do it again. Because, I mean, this is supposed to be good. Wait, what is that? Oh, never mind, it's the same line. Wait, is it? Wait, what? What is that? Wait, what is that? Wait, what? Wait. It's not supposed to be like this. Oh, wait, never mind. Yeah, it's just me that changed. We changed things. Yeah, I'm not sure. Why? Wait, why was supposed to be good already? It was all. Wait, what? Yeah, no, that's just bad. Yeah, I messed up. I messed up. So this is R. This is R. And this is code.y, I guess, probably. Is it? Yeah. And I'm gonna remove this. And I already know that test y is this. Oh. Now I'm gonna look a bit more on Google. I mean, I can like think about it, but it's like 5 a.m. So I don't really have like the faith to do it. I'm vibing, vibe coding. Because I mean, I tried my own implementation, I guess. I tried to get R. I tried to get the rest. It's like kind of working, but it's not flat. Wait, what about... Wait, I have an idea. I may know something about it. Position. No. The position seems to be fine. I don't know. Though I'm interested in deleting chunks actually. I want to see which chunks are causing problems. Probably this one. Right, I can't modify it really. What if I modify this? Because it's getting overlapped for some reason. And like I'm wondering if it takes the few faces that are just looking at the wrong way or not. Because there's a problem with that, definitely. But then when I go inside nothing changes. It doesn't become like, I don't know. But where's my mouse? Oh. Let me go back there. So I mean, V is good, right? So I'm gonna try something. Can I? Yeah, I'm gonna go to online C++. I'm gonna try some stuff. I could actually write a unit test functions. Would be good. So we have I love this. Here we go. It's a vector 3. NB cubes. I just realized, but no, it's just floss. That's good. And yeah, this is... I mean, at this rate, I might just make my own unit test. That's fine. So we have this. X is... What is X? This. Oh. Wait, what? So 15525. Good enough. Already big. And the last one is 2325. There we have this. Then let's say we have E, which is the point that we want to test. It's not constant. The thing here is, let's say it's gonna be 2, 5, 9. Okay. Then we have the big radius, which is this, which is a lot. And we have the small one that is like 2000. Yeah. Can't believe I remembered. Okay. Okay, so then we have our transformation. Like this. Okay. So now I wanna check a few things, okay? So R, U, and V. I'm gonna STDC out. R. I guess ideally I want to format. You know what, let's print F maybe? R. U. V. R, U, and V. Here we go. So it's gonna be this. And I guess we have the destination. I'm just gonna put everything here in brackets. Coordinates, wait. P... I mean... I guess it's fine. Plus P. So we have R, U, and V. Okay, okay. Let's have maybe have transformed P X, Y, Z, which is P dot X, P dot Y, P dot Z. Let's run this. And we have a little problem. I don't see the line. The end of the line. Where's the problem? 25. Oh. Okay. Strike definition. Right is not C sharp. Chord. Yeah, it's just B. I just control D. Nope. Okay. Math. Yeah. So it's still, so it's like pi times 2. Or like, I mean, I guess. Yeah, the standard library already has to, right? So here we go. To was not declared. What do you mean? To local. Is it C math? C++ to. It's math constants. I know it's there. Numbers. What? Wait. What? I mean, I guess I'm just gonna copy this. Oh. Let me check for pi. Because I feel like there was... I mean, maybe it's in C, but... 20... I don't want the 20. C math. Use math defines. M pi. Oh, it's M. Okay, so M... M toe. You think it's good? You know what? Let me just define the constant. What? Oh, that's fun. This. Like this. And yeah, it's just gonna be toe, portmanteau. Test. Yep. Ambiguous. Well, not declared. Yeah, I guess it's just not declared. Let's do this. Okay, so now we have results. I forgot to backline. We have this. And it looks maybe alright. So now what I want is... Let's say I have R, U, and V, okay? So let's say I already have those. Wait. P... Yeah, let's actually have P2. And this is just P2. We are also going to have R, U, and V. Well, R, U, and V. I mean, and I guess the constants are, of course, outside. So I guess it didn't actually matter, any of this. That's fine. What's the scope? I mean, that's fine. So here we go. We have all of this. I can run to verify that it's compiling. It's great. So what I want first, I want to test this. And it should be good, right? There's no reason it's not good. So let's assume we have the right U, V, and R. I want to check if I can get the right values back. U3. Yeah, I can't control the 3. U, R, and V. And I'm gonna print. And this is... well, P3, I guess. Math, where did I... Here. I forgot. Okay, so we have 2, 5, and 9. With some imprecision. Well, that's close enough, right? That's close enough. To me, it's good. What if I have, like, big values, though? Let's say this. And it's fine, as you can see. Like, the values are good. Great. It's relatively stable. It's stable. So now... so this is correct. Now I just have to get back R, U, and V. So I'm gonna have this, but 2. R2, U2, V2. And we're gonna try V. So V2 is this, a tan of it's P2 in our case, P2. It's the transform point, P2. Okay, let's first start with this. So V2 is this. And V is this. This is definitely wrong. What is wrong with this? Wait, did I forget? I forgot something essential. Well, transform P and... yeah, I forgot something essential. So this is the angle. What is this though? Well, not this. What is this? V. The amount of cubes. I mean, I guess it should be less. Or maybe not. No, it is less. Okay, so yeah, P is inside this though, right? So let's have something possible, shall we? Like this. Well, actually, 1, 2, 1, 2, 1, 2. That's kind of bad. Let's have some variations. So we have all of this, 3, and we have minus. It's like very different too. Is it? Wait, it's not. Because minus this plus pi. No, it is very different. Wait. Plus 2 pi. Here we go. 3, 2, 4, 2, 9. Okay, so this is good. This is actually good. Okay, and yeah, that's why... Oh, I didn't notice it, but GPT was actually doing the if for V2. So, I mean, let's do that. Really. I'm just gonna remove this. Do this. Do I even have D? I don't have it right there. Wait. So D is just a squared. Then we have R, which is this, which is good. We have U. And yeah, I want to just check if U is less than 0, then U plus equal math O. And I'm gonna do the same for V, because I wasn't doing it. So I wanna try with V. And I'm gonna continue testing in the meantime. Right, sounds good. Okay. What about... Yeah, so here. I computed V. V2. Let me bring the V2. I'm gonna use a thing. Then we have all multiple. Is it? Oh yeah, my bad. Yeah, that looks kind of bad. So R and U. I'm gonna copy this here. It's like R2 and U2. And I'm just gonna run again. Maybe not. So this one is P2. P2. 2. Remove this. Remove this. Remove the math. And we should be almost good. Yeah, D, I forgot my D. Alright. Okay, I'm gonna succeed. Oh. Let me just try this first. Okay, so we have R correct, U correct, V is negative. Oh, it's V2. And U2. Okay, so this is... Okay, this is correct, perfect. Wait, and let me just check the final coordinates. 1, 4, 2, 8. This is perfect. Okay, so let's try. It doesn't work. I mean, I guess we have a lot of cubes. We have those. So are there like the different chunks? No, they're not. There shouldn't be. Well, I mean, I guess there must be. That's like the only thing that would be logic, but yeah. I think my transformation is a bit wrong in the first... yeah. In the first place. But okay, yeah, the inverse is correct. Inverse is correct. So I just wanna try... Like, what happens if I have this and I just remove it? The space modifier I just removed. Oh, so this is not flat. Wait, what? Why is it not flat? Why is it not flat? It should be flat. Position. It doesn't matter. It doesn't matter. Why is it not flat? Let me remote. So you have different chunks. World position equals vertex. Well, world cards, I guess. What even is world cards? It's varying. Yeah, it doesn't really matter. Why is it... Wait, that's so weird. Oh, is it my camera? Oh, my camera is rotated. My player is rotated. Yes! Oh, that's so stupid. Oh, that was stupid. Oh, no, never mind. It's normal that it's rotated. Okay, the player was rotated. Okay, good. Well, it wasn't good, but now it's good. Well, no, it was a translation, though. It wasn't a rotation. What's the deal? Oh, wait, now it's good. Now it's flat, as you can see. So without a transformation. And okay, I wanted to verify that the faces were good and not like inverted. So I mean, okay, this is good. Perfect. Even. Let's bring back the transform. The torus modifier. Okay, now this is flat. Everything looks good, except that there is, well, there are, I guess, a few problems, of course. Okay, I get it. Okay, yeah, okay, it's working. It's working. The problem is that it's trying to loop. So the vertices that are at the end here ends up there, and it tries to connect triangles. So it's doing bad things, basically. Okay, I get it. So okay, yeah, it's working. So the inverse is correct. Can I actually... I mean, I guess I can't really. I don't actually need the inverse function for that. Well, for that. Yeah. Yeah, this is a bit of a shame, but this is fine. Is it? Yeah, I guess it is. So... Okay, let's say we have this. We have the inverse function, which is great. I'm just gonna copy the codes, this code somewhere. And like maybe make a unit test somewhere, something I don't know. Okay. So then we have the shader. I want to compute the inverse. Get the world pose to a +1. But this actually feels a bit complicated. So what do I even want? I guess I have the vertex. World's coordinates, okay. Vertex. Yeah, I guess it's the vertex, so vertex equal vertex time. So wait, what is it? Is it like a vec4? Well, it's a vec3, I think. So I guess I'm gonna make it a vec4 with 1. So it moves with my transform matrix. Maybe. I don't know the direction. Yeah, it's probably the opposite. Invade the argument. Yes, I'm just gonna get XYZ. Okay. And my transform is going to be something like so I have the wait. Do I actually care about this? Yeah, I kind of do. So like donut inverse transform. Let's say we're gonna put our, implementation, our code. And I'm gonna do camera. How do you say? Well, camera chunk first, I guess. So we're gonna do a little thingy like this. Here we go. Then we are going to do world spars. Let me think. It's like +1. Complicated. Was thinking maybe something like vec 3. 1, 1, well, 0, 0. But I feel like, I mean, basically for each axis. So x axis, I guess. Camera x-axis first. So then we have the difference. That was basically kind of the goal. So it's a vector. And I want to put that in the transform, probably. And this is like, for example, going to be the... How do I even set a matrix in the shaders? That column. I guess it's just like 0 equals this. But actually, is it? I mean, I want to translate, so it's gonna be wrong. Isn't it? Maybe not. Actually, maybe not. It's a rotation. Yeah, it's a rotation. Oh, it's a rotation. So yeah, I just need a mat free. Because I basically just want to rotate, probably. Oh wait, it's Is it? I need like the curvature of where I am, I guess. Wait a second. I just need to cancel every... Not every transform... Yeah, never mind. Ah, this is complicated. I need a plan. So yeah, basically what I have is... I have my... Can I increase the size? I have my donut. That is made from a chunk like this. But instead it's like warp around. And what I want is... What even do I want? Yeah. Instead of unwrapping it, when I am here, I want things to look Maybe like this. Wait, that sucks. What is this? Hmm. Let me think. Yeah, maybe what I want is actually wrong in itself. Maybe I don't have the right idea. Yeah, maybe I'm trying to do something like a bit not good. Basically, I want the current block to look like a block, a cube. Oh, okay, yeah, that's it. Okay, that's it. That's really only what I want. So instead of using like the whole inverse, maybe we can like use the angles and stuff, right? So let's say we have all of this. Our little block ends up being transformed like this, right? So the question is, how can I get it back to normal? First, we have this thing, the Y difference. The Y. What do you think? Photo vertex, is it in world space? Is in local space. Yeah, that's what I thought. So that's why I wanted to get the world position. Maybe somewhere, maybe not. I mean, I guess it's fine then. Because I don't need the world space, I only need the position relative to the view, to the one who views the thing. So let's say currently okay, so actually when we use the inverse, we get the angles back, right? And we get the R back, which is important. I may have an idea. Oh yeah, that's kind of stupid. Oh, that's such a stupid idea, but that should work actually. So we have the camera world position. Wait, actually, it's gonna be in world space though. But yeah, I'm gonna do not inverse transform. Camera chunk pause. And what? Okay, I get it. Okay, let's try to... Okay, basically I should not use the inverse directly. I should compute U and all of those things. So we have like V. It is this and this. 8 and 2. Do we have... Wait. Oh no. Oh no. Is it a 10? Yeah, it is. Like this? Good, good, good. Okay. I mean, I guess I can modulo this instead of if. Instead of having a if for like shaders. That's fine. Then you have the distance. There's the math. Then we have R and U. You know what? Let's compute. Well, find. I mean, I guess that's actually something I need to do on the CPU. I said it earlier, but yeah. Find parameters for like the position or the pulse. Find peruse parameters. There's gonna be this. I'm just testing in the shader because I can like test right away and stuff, right? It's faster. So boom, it's shorter. Boom, boom, boom. Math. Yep. 8 and like this. Big radius, right? Guess let's have this here. Big radius is this. Small radius is 2K. Chord is this. Okay, and now I should return vec 3 of U, V, and R. We have U. Then we have V and we have R. Right? And from that, we can balance things out, right? So we actually want to compute the... So that was like half of the inverse. We just find the parameters. And now we have those things to like change the destination and stuff. And that's what we want to do, but not on the camera position, but on the vertex. The problem is that the vertex is in local space. So I don't know what it's going to do. And the cubes. Wait, it's equal. Wait, that's a problem if it's equal. Wait a second. Oh no. Oh no. Do I actually have to render the chunk without the transformation? Oh, that will be... Oh, so incredible. And I do the transformation here. Nah. Yes, the problem is that it's not like a plus equal, it's like a whole transformation. So it's like a bit different. But I have to assume it's linear. I have to assume it's a linear transformation, right? But it's not really though, but yeah. Anyway, so okay, never mind. I'm not gonna do those computations. Instead, I'm gonna think for a bit. So we have U and V that are the angles. Then we have R that is like the depth. Okay. Is it? No, it's not. We have U that is like the big radius. We have R that is like the distance from there. Wait, actually no. But what are those? Wait. Here we go. So we have all of this, right? Maybe. Okay. So... surface. T... U... Okay. So yeah, R is like at what point it is inside the torus. And U and V are like the angles, but let me just think for a bit. Oh, no, okay, that makes sense. Yeah, okay. We have a circle. We have U that is like the angle of that first big circle. And then we have V that is like the angle around on the like that is perpendicular, like orthogonal to the first one, to the first circle. And then we have R. Okay, got it, my bad. Okay. So now that we have this, how do I do things? Okay, we have R. But R doesn't really do anything much, right? Oh no, it does. It completely does. Yeah, okay, R is like the length to the middle of the... The food is a torus. So I guess it's like a division. Wait, no, it's not. Yeah, it depends on the angle, actually. I feel like I'm just going to... No, I'm not going to invert the torus. Am I? I am going to invert the torus. At this rate. The problem is that I don't know what I want. The problem is that I don't know what I want. I feel like I want an interpolation and like a distance for the effect to apply, but not to go like forever. So it's like kind of complicated because of that. It feels like kind of complex. Maybe not. Wait. Yeah, if I see a donut, I mean, I can try some things still. Like vertex divided equal by R. Oh, that's gonna be so bad. Let me think. Let me check the... So we had tests. This. Tau. V R divided by small radius and V cube. Vertex. I divide by R. It's not about R, it's about... It's love it so much. I have to look at the donut again. It's like the deeper I go, because on the surface. Oh, right. Wait, do I have the modifier? I do have it. Wait, what? Huh? Yeah, that's why. Let me remove this. Close. And I want to check again the transformation, what it was, to have a better idea of what to do against it. Because when it's on the surface, it's not bad, but the deeper I mine, the more there is like a deformation. So it's like depending on R, that's for sure. But I'm not sure about like what exactly like it is, you could say. And like, yeah, the further away I am from the donuts, the more I'm going to see the donut like a real donut. So it definitely depends on R. And I think we need like the center of the donut to compute this. So let's try again. So we have this. We have... Oh, it's gonna be long. Wait, let me change the position. Something like this. Maybe? I hope. 3K. Yeah, I think it was maybe 2K. Wait, it's... Wait, what? Oh, right, no. It's a big radius that I want. So yeah, it was actually a lot. Oh. Wrong place, I suppose. I was using Unreal coordinates for some reason. Wait, I just realized. Never mind. Okay, so we have this. And yeah, this looks like a square, right? This is what we want. This looks like a square. This is good. Like kind of everywhere actually, here. But when I click and I go down, the further down I go, the more and more there is like this distortion, right? And this is what I'm against. So it's like when I go down. Oh, so I guess it's depending on like the radius, the small radius. Okay, interesting. Let me... Is it becoming bigger? No. Okay. So let's say we have all of this. UV and R. So R. So we have the small radius. this. Let me copy. Nope. I love it. We have this minus R. So when we are on the surface, it's like R is 2k. So basically by doing this, we get the amount of distortion we want to compensate. Distortion alpha, I guess. And well, alpha is not between 0 and 1. Actually, we probably want it to be between 0 and 1, right? So it's R. Yeah. Just like this. But with a 1 minus before. And then we have something like what is it? I mean, I guess we have the center of the donut. We have U, so we have to follow the U though. The U in local space. So I guess we need the donut origin in local space. In view space. I mean, it's gonna be 0, so that's fine. Oh, but there's I mean, I guess then there's the angle, right? Is it gonna change the thing? Yeah, probably. Yeah. Axis. I mean, I guess X, Y, Z. In world space. Camera world's position. This is a bit tricky because so many conversions that I'm gonna have to do. Vertex is a vertex. Local space. Maybe I should convert like things in world space to make it easier, and then try to optimize. Yeah, because right now I have a referential problem. Find tourist position. So I mean, this one is good. So it's in world space. I mean, makes sense. UVR. I mean, I guess I need the vertex world space. But like... vertex world buzz, I guess, is model matrix times like 4 vertex. Like this. Expected something, yeah, here. My bad. So okay, we multiply by the model matrix. Wait, that's not what I want. Is it? Wait. It's in local space. Wait, what? Yeah, that's not really what I want, is it? Because I mean, it's already supposed to be like in world. Is it? Wait. I mean, it's in 0, 0, no rotation anyways. It's like the identity, right? So that means it's already in world. It's already in my... Okay, anyways. Yeah, what happens if I do this? It should just be the same, right? I'm just a bit curious. I don't... It is actually the same. Okay. Anyways. Okay, I've been a bit confused, I guess. But I guess it's a bit better. So we have the world space. And I guess we can interpolate or something. Maybe. Maybe not. Camera world pose. So the closer I'm getting to the center, the more I mean, I guess I need this too, right? For like the vertex. Like vertex arams. Vertex parameters. Okay. So now that we have the OR, Okay, I think this is it. So... well, this is it. Okay, yeah, I think that was the missing link. So we have the R. And if it is less than the player, then U and V are going to be a bit bigger, maybe? I don't know. And in that case, we're gonna move in that direction. Maybe. So vertex R. Yeah. So yeah, that was the distortion alpha. It's actually a bit different. Is it? So the current R minus this. Not really though, is it? I want it to be local though, that's the problem. I want it to be relatively local. Maybe the way I'm doing this is wrong in the first place. Is it? Vertex fold position. So yeah, I guess I would have to multiply by the inverse of the model matrix to assign it to the right value though, but yeah. Something like that. Or like maybe put those set vertex world position. Yeah, that's what I thought. So unify its vertex in world coordinates. Wait. Render mode. Wait, do I have inv model matrix? I don't, right? Yeah. Wait. Actually. Yeah, okay. Change vertex position. Wow. So a vertex depends on the shader type and the render modes being used. Special shaders. So I have a special shader, right? By default, vertex variable in 3D is in local space, also known as object or model space. This means its coordinates are relative to the origin of the mesh itself. Yep. Not space if you add manual conversion. Yeah. Wait. Oh right, I forgot. Okay, never mind. Okay. I mean, I guess I can just do inverse this and wait a second. Oh, okay, so let me bring back. Hey, muted. Hey, Daniel. Yeah. I just noticed. Since how long? Wait. No longer. Yeah, it was. And I just remember. Yeah, it wasn't for long. It was for 2 seconds. Itself. Yep. Probably. Okay, so yeah, how are you? I'm trying to do something I don't understand. So yeah, it's a bit complicated. So vec 4. Something like this. So is this that XYZ? Maybe. And yeah, it's just supposed to be the same. Shadow completion, invalid arguments. Oh no, okay, it's good now, right? Yeah. So you just shouldn't change anything. New batch of donuts today? Look at this. I have I have this. I have colors. I have the lighting, like the normals that are working well. And, you know, I can just destroy blocks very fast. And right now the goal is to... Well, basically, you know, it's all good and fun, right? I do not throw an exception. It was a circular dependency issue. Oh no. But yes, the problem is that the further I go in, the more it's like distorted like this, right? And it's not good. It's not really what we want, right? So I want to do something about it. Oh wait, I might have some idea. Oh no, it feels like the Japanese horror comic. Oh no. And I don't know what kind of transform I should do. Because if I make it like a true cube, into a true cube, then that means it's just going to be flat around, right? I don't want the... I don't want to invert the whole transformation of the whole donut, because then it's just going to be like a simple, you know, chunk, a normal chunk. Well, I want to cancel the transformation of like the block that is next to me and use this same transformation for the other blocks, but not cancel them. But it's a bit difficult because it's not a matrix multiplication. Maybe it should be. I mean, I think it should be, like, intuitively it should be a matrix transformation. But I have to find it because my default transformation is not a matrix. Japanese plus comic. Oh no, what have I said? I mean, it's comic. Like, you actually only have like Westerners saying like comics. Well, shaming people for saying Japanese comics. Like in Japan, you actually have like the word comic everywhere. Like you have the comiquette, right? With like 99% mangas. Let me go up. So it's getting smaller around the V, probably. The enigma of Amigala Fort. Junji Ito. Oh. What is it about? I'm losing my ability to speak, but that's fine. Maybe not. I guess it's Z. Let me try something kind of stupid, but let me try something. So we have the world's position. And I'm just gonna do this.z plus equal distortion alpha. Maybe. And maybe it's gonna be like a times something, but yeah. And let me try again. Story follows a massive earthquake that splits open. An earthquake in Japan, oh! That opens the mountain, revealing thousands of strange human-shaped holes. What? People become irresistibly and psychologically drawn to the mountain, compelled by the belief that a specific hole was made just for. Driven by a terrifying compulsion to enter the halls, only to have their bodies slowly stretched, comforted, and permanently warped as they squeezed deeper into the rock. My god. Oh la la. Look at this! Wait, what was that? Let me go down. Huh. I'm not sure about the directions. That's the problem. The directions. So let me take the player. Move in Z. Z. So yeah, you have to... Oh, I have to increase Z. Yeah, I'm just doing a plus. That's stupid. It's like a times equal or something that I need to do. Well, equals... Wait. Times equal 1 plus this, maybe? But it's just a plus. Hey, just moving, that's stupid. No, times equal. No, never mind, it's not. No, it's different. So yeah, it's basically plus equal... Yeah, that's bad. Is it? So all. So at the surface it's 0, and when I go down, I want to increase things. So yeah, that looks good. What if I do this? Oh, maybe it's like the size of the... Oh, it's like the... small radius size, maybe. It really feels like that, going into the hole. Yeah, it does. Planets should have, like, gem inside them. Would be more planet-like. But at least some planets, like Earth. Wait a second. I don't know what's happening. Wait, I'm outside of the donut, am I? What's happening? That's a chunk, though. I'm outside? What the fuck? Okay. So let's put a limit to this, okay? If this is higher than 0, I do things. Override, I don't. Override, I don't. Please. Okay. Let's go out of the donut. Okay, so it's good. Okay, it's good. Okay, perfect. Okay. Let's look at this. Oh my god! Oh my god, what's happening? Yeah, maybe that's a bit too big for me. Yeah, the transition is pretty brutal. And I guess it's not about the camera, it's about... I mean, yeah, no, never mind, it's about the camera. The horror manga. The squeezing transition was slow and painful. What kind of books are you reading? I mean, I guess it's a manga, I guess that makes sense. So if I go down... Is it at least scale? Okay, scale in the right direction. At last, it's at least something good. And... Z. Is it really this one? I feel like it should be this one. Yeah, it's probably this one. So it's X. Anyways. So yeah, I'm gonna probably divide by this. It's just, you know, a feeling. It's just a feeling. And it seems to work. Look at this. If I go down, maybe it doesn't. Yeah, because some things are breaking. I know. That's fine. Does this make you smaller the closer you are to the center of the donut? Or the walls actually squeezing you? They're not supposed to squeeze me. Yeah, why is it squeezing me? I mean, I guess it makes sense. I guess I'm just trying... Okay. Let's try the same in... I think it was X, maybe? I feel like things are going to be pretty bad. 2, 3, 2, 5. Yeah, maybe it's maybe you're right. Maybe it's like this. It's the other angle that makes it a bit weird. Wait. So it's a square. Definitely a problem. I'm asking because... What if you mine a huge chunk of blocks? Would it still make you smaller? That's a good question. The goal is for it not to be... Well, yes, actually. The answer is yes, but my problem is that I don't have the right transformation. That's the only problem. I mean, right now the player is not made smaller, that's the thing. It's because it's a donut. And like the cubes are not actual cubes. So the cubes are... You know. You're just digging. And the goal is to make it look like it doesn't change. I mean, I feel like things would be like a lot easier if I just kept it like an illusion, but yeah. Let me ask ChatGPT. I'm stuck. When going inside the turrets made of cubes, the cubes start stretching and don't look like cubes anymore. I want the player. Well, the view of the player. View of the player? Yeah. I want to modify the view of the player so that every near cube looks like an actual cube, an actual undistorted cube, but I don't want to undo the torus transformation and wants to keep the cubes that are far away kind of that shaped still. That was a long question. So if after that was missing, like gods took a bite, if you flew there in the empty space, you wouldn't get squeezed, right? It's not about getting squeezed, it's a deformation of space. So you wouldn't feel like you're getting squeezed. But everything around you would kind of change. And I guess like usually, like you know how like in our world, like matter deforms space, right? That's why you have gravity, right? So I actually was thinking about something a bit similar. But of course, if you start like destroying the world and stuff, like changing it, like it would be a bit complicated. Deformation of space, like a gravity. Well, man, the donatory system is so complex. Yeah, well, I don't know what donatory system is. Monetary system, no. Donatory. What? Donatory. Donatory. Planetary donut. Oh. Oh, yeah, okay. Yeah, okay, I get it. Yeah, there's actually something on the net about it. Yeah, got it. Got it. So it's a non-Euclidean... Yeah! Yes! The whole geometry remains torus-shaped, but you want the player's local neighborhood to appear as... Yeah, you're so right. You're so right. That's what I want. As if it were still embedded in the original cube space. Yes. Non-Euclidean. Conceptually, takes the world position being rendered. Pitorius. What? Oh yeah, the world. Okay, so I already have the world position. Apply the inverse torus. Wait. To get the original cube space position. Okay, I have the inverse. Compute the position relative to the player. In cube space. In cube space. So I need to call the inverse torus mapping on the player too. Okay. Project / render using that cube space relative position. Wait, really? Can I just do that? For distant geometry, it gradually blends back towards the... Oh, so I blend. Oh, yeah, there's the blending. Oh, that's where the blending was coming from. Oh, that's so good. Filthy vibe. Filthy vibe coder. Actually, I've been using codecs for 2 weeks to code a website. Yeah. I mean, I tried doing it on my own, and I actually had like a lot of ideas similar to that. I was thinking about having the inverse, right? That's why I made the inverse function. I was looking to make it. I was thinking about like the interpolation. I knew I was gonna have to interpolate at some point. I just wasn't sure of like what to do, I guess. Then render using final pulse. And for Y1. Tricky part is where to do this. What? And there's a world in cube space. Yeah, I was actually thinking about that, but the problem is if we have other people. Mathematically cleaner because cubes remains cubes everywhere, which requires custom ray generation / projection. I mean, this is fine. I mean, I kind of did that already before. For voxel games, the first approach. I mean, yeah, my question is, if I deform everything, what about multiplayer? Well, not multiplayer, but... I mean, there are like multiple programs about it. I don't want to think about it. Let's just do things this way. Find torus parameters. So that's like the inverse, right? So, well, suppose let's have cards. Boom. Then we are going to have so we have all of this. Well, I actually don't have the fix for you. For you. Here we go. Boom. So the goal is to remove the if at the end in the shader because of optimization. And then I have dest like free, and I return this. And I guess I have the amount of cubes and everything. So a chunk, yeah, it's not chunk size. It's like NB cubes. I guess. For now, I'm just going to hardcode things. That's fine. Okay. Okay. I return the destination. So it's supposed to give the inverse. Let me look at the chats. Oh. Okay, so we have the inverse. Let me just look again. Not at the donatory system, but not at this. At this. So what we want, apparently, is let's remove this entirely. Maybe not. Yeah. Yes. So Pitorus and Playatorus. I have to find. I actually have the inverse for. I actually was finding the parameters. Yeah, I was trying to. I think I was gonna replicate the thing if I had to continue. So camera, chunk pose, and it's going to be donut inverse transform. Okay. Then we have vertex fold pose. And we have the inverse transform. So vertex chunk pose, I guess. Yep. So local cube. What? So wait. Yeah, okay, this is a cube in local space. So it's like vertex PQ. Well, player. Wait. It's like player to vertex. Or like chunk space player relative cube. How can I call that? I guess local vertex in cube space relative to the player. Well, local to the player. So it's gonna be vertex chunk pose minus camera chunk pose. It's not really chunk, but yeah. It's like the space. So then we have the local torus. So what is Pitoris? Oh wait, that's what? Oh wait, that's a space relative to the torus, is it? Several position being rendered. Never mind. Yeah, that's fine. Yeah, okay, torus is just a world space. Actually, okay. So local, well, not local. World space. My God, it's so tricky. How can I call my things? So what I want is basically this minus the world position of the camera. So this is chunk pose, chunk pose. I mean, this is basically camera to vertex chunk space. And this is the same but in world space. Wait, is it? AB to B minus A. Yeah. Yeah, this is it. Then I guess we have the smooth step. Like alpha. Because we want the interpolation. So near distance, far distance. Let's do... I don't know what it's supposed to be. Well, I mean, I have my idea, but like the values, I don't know what values I should put specifically. Smooth step. Oh, right, never mind. Let's put still of like 10, 100. Well, 50. We have near, we have the far distance, we have the length of... So this is what's going to interpolate. Local cube. What? Right. This is it. Yeah, okay, that makes sense. Yeah, that makes sense. And then the final position. What is it? I guess it's the vertex world space. Is a lerp between the local... Oh, right. So it's actually a vertex, isn't it? So it's a lerp between blank space and world space. Oh, that's so smart. That's so smart. I understand. What? How stupid. Am I not closing my... Wait, what? Am I checking for... What? Oh, it's a mix? Is it? Yeah, ChatGPT says lerp, but it's probably a mix. Like mix is just lerp, right? Is mix just lerp? Yes. Perfect. Please. Onegai. Kamisa. Attends. What? Something feels very wrong. So we have a donut. Right? And here we go. And the deeper I go, yeah, there's still a problem. Like here, it shouldn't be like that, right? But I understand what... I think ChatGPT is right. I don't think it's bullshit. I kind of understand what's going on. Let me verify that I have... That's good. Then render using final pairs. Near the player, cubes appears perfectly cubic. Far away, nah. Tricky part is how to do this. Should I like do this? I just wanna try, but I'm not sure. Does it only apply to the chunk you're in? No, it's applying to all the chunks. There's definitely something a bit different. But I don't think it's what I want. I can't break anyways. Yeah, it's not working anyways. Wait, what was I? Yeah, no, that's fine. 50, 100. So yeah, now I just have to fix it. I think the computations are right, but they're just not adapted to how I render to the screen. So how can I render to the screen through that? From there. Let's specify I'm doing that in my shader code in the vertex shader. How can I render to the screen from there? Well, how can I render? How can I proceed from there? What space are you modifying? Even simpler, final pose equal this. Factor depends on distance to the player. Local flattening. For each vertex. Inverse, that's what I'm doing. Then cube, relative. Then we have positions. Yeah. I mean, that's what I have, right? Camera to vertex chunk space. And I have D, which is the length. And I have the factor. Wait, it's 1 minus. Smooth step this time. That makes sense. Wait, flatten. No, that doesn't. Wait. Flatten radius plus transition. Yeah, that's like the near and the far, right? I know. It's like... Okay. So it suggests a 1 minus there. Near the player, 1. Far away, 0. Oh, right. Yeah, that makes sense. Wait, am I stupid? I don't know. I will leave you to it and go watch this funny puppy anime I found on Netflix. Okay, enjoy. I guess it's 1 minus, and then flattened world. Wait, what? Okay, let's try this. So flattened. So wait, we have the alpha, the factor. Player plus cube. Wait. Okay, so it's expecting the vertex to be... shit. Let me go back. And do this. Oh, I actually already had it here. Okay. So, let's say I have this. I have... this equal the current one next to the flattened world version, which is the player camera chunk pose plus plus vertex chunk pose. Yeah, that makes sense. Yeah, okay, that makes sense. And I don't think that's gonna work actually right away, if I'm right. I think I understand then. What the fuck? I think I understand why it's not working too. Up. Actually, what is that? That's crazy. Yeah, that's literally crazy. Okay, so... okay, I get it now. So we have... big, small... okay. Everything's good here. Camera. And the vertex. And we do want the plus. Okay. But the thing is... it's gonna give us coordinates that don't relate to this at all. Hey, machine. Hello, witch. Hello, how are you doing? I'm good. What about you? Trying to make donuts? And a lot of math. And a lot of math. Good, thanks. Oh, great. Trying to make a non-Euclidean donut. My god. Camera chunk space. So, okay. I do this. It's not gonna... it has to be in the view... not in the world space, but in the view space. You're trying to make donuts? I am. Definitely. And even ChatGPT doesn't get it, I think. Modify the camera transform. Let me think. Modify the camera transform, what do you mean by that? Wait, yeah, maybe. Modify the position relative. Yeah, that's what I was saying. Modify the position relative to the camera. Oh, I'm so glad I'm so right. So, view pose. Yes. Yes. Yes, this is what I wanted to do. Okay. Jacobian. Transform stretches cubes because it's not distance preserving. For torus, the circumference scales. Instead of fully undoing the transform, you can compute the local scale. Can I? And locally rescale vertices around the player by the inverse. Much more like a normal world. Option 2. Yeah, same. Yeah. 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 Yeah, I wanted to do like the view. I was saying that in world space it wasn't good, right? I'm so glad I was so right. That means I understand things so much. I'm glad. View pose equal instead. Yeah, the view pose is going to be a bit different. So we have the world pose for the chunk, well, for the camera and for the vertex. That's good. Then we convert to the chunk pose, so relative to the donut before it was a donut, to the space, relative to the space, yeah. And then you can blend. Wait, that's not. Wait, what? Local torus. Yeah, so, yeah, okay, yeah. So we have things. Alpha. So we mix, not from the vertex to this, but minus camera pose. So world minus camera world pose. And these ones should be relative too. That's what's a bit tricky. That's what's a lot tricky. How can I convert that back into world space, kind of? Wait. Local torus, local cube. And local cube is supposed to be cube pose minus camera cube. Wait a second. So it's like this. Yeah, you already had this. Here. Like here. And we have the alpha directly. Okay. Let's try. Yeah, have you finished the game? Sorry, I'm asking because it's been a while since I've been here. On Cento, I guess it became a bit complicated. Because, you know, I was doing that like with a team. And they had like other things going on. Wait, is it actually working? Because there's definitely a distortion. Okay. So let's look at this. We have cubes. Okay, what if I go here? It's not cubes. It's not working. Yeah, something is like really wrong. Let me just do this. Oh, I see, yeah. But I'm trying to make a new thing in the meantime. Well, in the meantime. I guess I started going on a new thing. And it's a donut. And the goal is to like make it some kind of game. And the goal is to basically make some kind of world that is very flexible. Well, some game that is very flexible about chunks and voxels, so that you can build, like, create your own weapons, for example, that are like voxel based, so that you can make your own vehicles, your own spaceship, and just, you know, continue to build inside, go from planet to planet. Maybe one planet is going to be donut shaped, and one planet is going to be sphere shaped, and one planet is going to be made of cubes, but another one is going to be made out of polygons. Like, not polygons, like hexagons, right? Oh, I see. So yeah, I guess that's kind of the idea. But it's a bit complicated. A bit hard. A bit difficult. As you can see. I wanna check. Yeah, no, it's not squared. Well, I mean, I just removed the shadow anyway, so yeah. Camera to... Wait, that's not good. Wait, that's normal. Let's instead have the... that's the vertex. Wait a second. No, okay, I'm mixing. That's good. But it's not world pause, it's relative. So then I have to do a plus player world position. Camera world pose, like there. And yeah, how are you on your end? What are you doing? What are you up to? Oh wait, it actually looks fine. I just don't understand what I'm doing, but I don't understand where. Okay, my directions are wrong. Like, I'm trying to advance, but I'm going to the right. So when I'm going up, at least I'm going up, right? And it seems to be fine. What the f... Why is it rotating? That's so crazy. That's so cool. And that's why the world is like distorted. Is it? Yeah, there's something wrong. When I try to go there, the world just warps. That's so sick though. Right? Let me... Can I destroy like this? Ah, it's too far. Let's destroy this. Yeah. Yeah, it's like rotated. It's rotated. I really want to push this though, because this is like so cool. Let's push this. Right, I forgot something. Oh no! I forgot something. My project is not in a Git repository. I mean, I don't have a lot there yet, but yeah. Let's do... Go to voxel game. Go to add a readme. Private. And I'm just going to, yeah, push things before I forget. Okay. Yeah, I'm just gonna move this. Guess it's fine. Go to voxel game. Can remove. Now I can push. So like all of this, I guess. Wait, what am I? Master. Let's create something. Something? I don't know. Yeah, I wish I pushed earlier so that I could like... Basically, I want to make maybe videos like devlogs, and I wanted to show like the progress and stuff. But I forgot to push the editor. I mean, it's not like I have a lot, I'm gonna lose a lot, right? But yeah. Log. Wait. Yeah. So it's like git commit m voxel 3 git log. Well, git, what was its status? So basically I added the inverse, okay. So I guess it's 4. And it is Taurus distorting rotation. Well, when getting, well, cool donut distortion when getting close, I guess. And here we're gonna have to, I guess it's voxel 4. Torus transform, well, inverse transform, I did. Okay, here we go. So okay, we have this, but it's not good. And the reason I think is because there is like some, I mean, there's definitely some problem with like the rotation, the orientation. So maybe I need to swap like X and Y, maybe for the chunk. X and Z actually, not Y. Chunk pose. Chunk pose. Wait. Camera to world space. Camera to vertex chunk space. Yeah, maybe like do I have a swap? Nope. Oh, do I have this? Oh. Okay. It's reasoning. What about this? Oh wait, no, it's not. Shit. It's with Z that I wanted to do that. Okay, let's go out of the donut. And it's not working at all. Wait. It's kind of neat. Oh, look at this. It's fine. It's just that Z, I think, is reversed. So maybe times -1 would be good. Please, please. Oh. Oh. Look at this. No, it's not working. Yeah, it was only when I was local. But I mean, if I continue right now, it looks flat, kind of, I guess. It's so bad. But it looks like something. Let's go from near is gonna be 0. And farthest is gonna be 200. It might be a bit better. Okay, so like this. So yeah, it looks like a cube, and now when I go forward, there's like some distortion. But it's fine. Right? Maybe? And when I go down... Yeah, so it looks like relatively flat right now. And... Okay, when I go down... Oh. It's fine. Let's dig and let's follow the digging. Oh my god, look, it looks like a cube. Oh my god, I'm so glad. It's working. It's working. I just have to take into account the transformation for the movement and the physics. Oh, that's gonna suck so much. Oh, and the raycast. Okay, that's gonna be fun. Kind of. Not that much. That depends. It's gonna take a while, I feel like. But yeah, as you can see, like, even if I go deeper now, it's like cubes, right? And the shape stays like a donut. It's still a donut. It's just a bit weird when I look like around right now. But if we increase like this, like 2000, is it gonna be alright? I feel like there's going to be some problems actually now. Because the radius is 2000. But actually if it's just the radius, it could be fine. Yeah, okay, it looks alright. It doesn't. Oh my god. Wait, what? What am I doing? Okay. Yeah, I'm not sure about this. But I can go forward. I wanna see if it's like fine, like even if I go like, you know what, let's increase the speed. I'm just so slow. Right. Times 10. Is it gonna be good? Congratulations, thanks. Yeah, definitely some problem. Yeah, it's not working. It feels close, but then there's this thing. Yeah, I'm not sure about this. It's about the chunk position. I'm not adding it properly to... Okay. What can I do? So yeah, the problem is probably when I'm trying to add the position, well, to interpolate the position in chunk space to this, because obviously it's not the same referential. So I have to multiply it by a transform matrix. Maybe not, maybe plus, maybe the view. Plus camera world position. Wait, actually this is fine. Well, this should be fine. Oh, maybe I need to do that beforehand. So, okay, I have my ID. What if I do like this? Wait, should I? Yes. Yes, definitely. And this is camera world space. Wait. Vertex. Actually, vertex world space. Yeah, okay, this is it. And camera to vertex chunk space. So we have the delta, but we add the world position. And I guess there's maybe the scale to take into consideration. But it should be maybe a bit better. Oh. Okay, let's pray. Pray with me. Oh. Whoa. Whoa. I mean, yeah, okay. Let me reduce the distortion distance. I don't know why it's like moving like this. I mean, I know that I should probably multiply by something. I mean, maybe this again. Oh, 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 oh. Oh, look at this. It's perfect. It's perfect. It looks flat. Kind of. It's a bit weird how it's like in one direction it's like, you know, you see the rest of the donut but not there. Yeah, it's like, okay, yeah, and there's like the demon ready to creep on me again. Never mind. Let's go down. Let's go the other way. Yeah. Problems? Yeah, yeah. It has to look the same both ways. That's the problem. And if I dig. I mean, it still looks like cubes though. So this is correct. In a way, it's just the interpolation. That's just kind of bad. Oh my god, the movement is gonna be so bad. Okay. I mean, it's kind of good progress in a way. But there's definitely something wrong. So let me think about it again. So we have camera world position. Okay. We have the camera in the space position. Then we have the world's vertex. We have the chunk vertex. Then we do... Hello, please! You're participating in GMTK Jam, right? Yeah, I've been multiple times. I feel like it's been a while. You too, right? What game did you make again? Please. I mean, it's a chicken game. It's a chicken game. I'm not sure I remember. Do you remember it? Can you send the link? I'm going to remember it right away when you send if you send the link. I can give you a link. Yeah, sure. Go ahead. World chunk. Hey. You can play the game on there. Mirrors discover transcend. What? Oh wait, it's... I need... Oh yeah, it's the recent one. Yeah, the most recent GMTK. Yeah. Wait. Wait. I haven't played this game. The newest version is on the website, actually. Oh. Yeah, I haven't played this game. Can play it now. My sleep says otherwise. But I mean, yeah, if I make a jam stream, feel free to just, hop again and share the link again. That's so you can see the video I made, YouTube Shorts. Oh, this one.
I made a chicken game in 4 days for the GMTK Game Jam, and
Wow.
I need your help. This jam has almost 10,000 games, and
Wow.
Bob here needs attention to survive. This year's theme was Loop, which I predicted, by the way. So me and my team agreed to make a game about the saying, which came first, the chicken or the egg? And so Bob and his egg were born. But wait, Bob's egg fell off the coop, through the sky, and into the ground, spawning Alfredo the chicken and his egg. And now Alfredo must make it back to the top of the coop. What could be waiting for him up there?
What could be waiting for him up there?
Find out. So
Oh,
give
no.
this game a try by clicking the link in the description and trying out this game on your browser.
That was nice. Alfredo, I like how positive you are. What do you mean? I wish video was the one you made. I don't think I made a video. Well, I mean, I basically have live streams of me playing jam games on my channel. So you might have seen me there. Oh, new subscriber. Oh, 2 new subscribers. Oh, thank you, G-Man and Play. So yeah, if you wanna check my YouTube channel, feel free to look and subscribe. I have like a few videos, but it's basically everything is in live, and I have my replays and playing jam games. If I go further, there are jam games, Boss Rush, Brockies, Pirate Software, Game Off. There's like the Metroidvania somewhere, Ludum Dare, Beat Jam, 1-Bit Jam, Brockies, that kind of stuff. So yeah, if you want like some feedback on your game, on a jam game, feel free when I'm making a stream for it. I follow age. Thanks. Let me think. As if it was the same. Yeah, the distortion is not good. So camera to vertex chunk space. So... Vertex world space, not really. I want to interpolate in the view relative to the player. So I think it was fine as it was before. Oh! Pardon français, ok! Ok, ok! Bonjour, bonjour, baguette! Comment ça va? Comment ça va? Je sais un peu de français. Oh, tu connais un peu le français. Pas mal, pas mal. Bene. Hmm. Camera to vertex world space. So we have this, we have camera to vertex chunk. Yeah. I think I understand the problem, kind of. Vous êtes français? Yeah. Yeah, I'm French. I'm native. Oui, 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 oui. Oui, oui. Oui, oui. Yeah. There's a logic issue somewhere. My French is very bad, I mean. Where from? I think it is. Oh, where? Oh, oh. Où is où is où. 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 D'où tu viens? From the center. From around Lyon. I've lived in Paris for a bit too for my studies. You know Alexien and Félix Lebrun? I don't think I do. No. I actually don't follow a lot of French things. Top table tennis players from France. Oh, okay. Yeah, definitely not. Definitely didn't know them. I play a lot of table tennis. Oh, nice. Is it your favorite sport? Or do you have one that you prefer even more? Yeah, let me check the Laplacian. I feel like the Laplacian is maybe better suited. Well, not the Laplacian, it's the Jacobian, my bad. Best cube preservation. Yeah. It's not distance preserving. For torus, we have this. Circumference scales. Yep. Inner cubes gets compressed and outer cube gets stretched. Yep. So fully undoing the transform, you can compute the local scale. What? We locally rescale vertices around the player by the inverse of these factors. This produces a result that looks much more like a normal world. Yeah, I'll go with this, probably. He said so. It is my favorite sport, but I also like swimming and tennis in general. But I will go back to studying for final exam. Oh, good luck, good luck. Hoping it goes well. And thanks, good luck with your work, Mr. Game Dev. Game Dev man. Thank you. You too. It was nice to have you here. And yeah, feel free to come back anytime. Um. Hmm. Hmm. I just have to know what I'm doing, which is complicated. Let's go there, maybe. Yep. Okay, so here, what do we have? Oh. Let's check the Jacobian. Torus mapping, so we have this. Do we? Wait, I'm actually not sure about this. Sin. Yeah, that's it. Because you know sometimes there is like they replace the U and the V, or like they have cost sin instead. So I'm trying to make sure. The Jacobian is this. Columns correspond to directions. Directions. Yeah. Okay. This is what I wanted. Yeah. This is what I wanted. Local stretching factors. Notice that this distortion comes almost entirely from this. Shrinks on the inside of the donut. Yeah, this is mostly... Yeah, this is perfect. The full Jacobian matrix inverse. You need the local tangent frame and stretch direct correction. Okay. From the vertex world position. Oh! This is what I was doing. I wasn't computing the total inverse. I was just getting the parameters. Because I thought you could optimize it. Oh, okay, that's why. Oh my god. Okay, this is what I was doing. Corresponding scales are... What? ER, EU... What? Okay. EV. Oh, or UV. So wait, what is E? I think it's like... Anyways. Corresponding scales are this. Wait, what? Oh, okay. Suppose you have a... No. Wait, what is that? The local tangent... Oh, yeah, it's the local tangent... Oh! Okay, I get it. Corresponding scales are... Wait, what? I'm a bit lost right now. I'm a bit lost. Construct the Jacobian. Okay. Okay. Wait, it's just... Float times float is a float. It's not a mat free. I get the inverse. Then for a nearby vertex relative to the player. Convert to cube metric. Yeah, I know that. Well, no. Yeah, anyways. Optionally back. However, for voxel cubes, there is an even a cheaper trick. Dominant distortion is along the torus ring direction. Inside of what? Outside. So you can locally undo only that stretch. Do you understand anything? I don't. So you have the local. World minus player. What? Oh, the vertex position, right? Yeah, yeah. Then we have the local. Much cheaper than a full matrix inverse. Okay. For the voxel game, I tried this first before implementing a full Jacobian-based metric correction. Okay. We can try that. I'm not sure though, but yeah. I mean, it's like some optimization, right? So world's local vertex. Well, world's player to vertex, I guess, is going to be the vertex world's pulse. To the vertex. So this first and the camera next. Then we have local minus equal EV. Well, wait. Writes the full data code that does that. What? Okay, yeah. Inverse torus. I actually already have that. So world pause. Torus, I get the inverse. No, I don't. Actually. Okay. Okay. So we have this from the vertex world pose. Vertex torus params. I mean, I guess it's like the torus coordinates actually. So we have R. Wait. It's gonna be a bit different. That's fine. So U and V. Okay. Then we have EV. That is for the Jacobian. I guess. That is like 3 minus big radius plus R in this case times sin of U. All of this times sin V. Big radius plus R plus sin U. I guess it can be optimized. I mean, the shader should be able to see that and optimize ahead of time, ideally. So we have EV, we have the local. So local is player to vertex worlds. Well, this. I guess we already have it. Ring amount. What is that? Oh. So this world player to the text. So it's a world, and we dot for the Jacobian. Okay, yeah, okay, I get it. Is to compensate. Wait, no, it's a flat. Wait, okay. Okay. Anyways, it's not. Yeah, it's an amount. Oh. Okay. Over comp. Whoa. Which one is that? Local is this. Minus ring. Oh, we have the ring component actually. Seconds. This is the amount. We have the ring component. EV times ring amount. We have the other component, which is ring component. It actually is like, it's like a lot, but I'm having faith. Big radius plus small radius times CNU. We have the correction. Yeah, it's totally vibe coding right now. I want to see if it's like, before trying to understand, I'm trying to see if it works. And yeah. Correction, big radius, divided by max between scale. And this, I guess. Because we don't divide by 0. Then you have ring component times equal correction, maybe. My god. Like 3 corrected. Oh my god. Over component plus ring. Then we have dist, which is the length of world player to vertex. Then we blend, I guess. Smooth step. 10, 30, and the distance. Then we have maybe final world position, which is world's vertex world pulse. Plus, oh, it's a corrected. Okay, yeah, this is good. This is what I wanted. Corrected local minus local is this. Times blend. Yeah, it makes sense. Maybe? Does it? Wait. Yeah, okay, it makes sense. Yeah, okay, this is good. This is good. Final world. Then we have the vertex, which is what I was doing earlier, right? I just convert from the world coordinates to the model thing. Okay, here we go. Okay, I'm really hyped right now because I feel like this might finally be it. It didn't make sense how it was before. Okay, okay. Look at this. Oh my god. I think it's good. I think it's working. Hello, oh, Project You Gamer. You're coming like such at a good moment. Look at this. I have my donut. Okay, it looks good. And when I come closer, it's looking a bit more big, right? And when I dig, it doesn't work. Wait, does it actually? I don't know. No, it doesn't work. Okay, interesting. I mean, okay, my speed is like 1000. So I think this is like, you know, maybe I should increase the blend. Okay. So no. It's not working. A shame. A shame. Is it actually... Oop. Vertex equal... Yeah, I mean... Yeah. Vertex... Oh! Wait, no! No, 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 no! I was wrong. I was using the wrong variable. Hope. I have hope. I have so much hope right now. Yes. It's flash. It's not flat. But it's not a square. From 1000. What's the radius too? Yeah, something is definitely not there. I feel like it's almost ignoring everything. So we have this vertex world's buzz plus corrected. What about the blend? Nope. So corrected local. Yeah, is it like 0 or something? This only compensates for the major ring distortion. Oh no, that's where most of the cube stretches come from. Wait, what? Inside the donut hole? Yeah, it doesn't really do that. Because the outer edge... okay. Vertex own or UV can cause neighbor... From the player position and use a single correction frame. Yeah. Touch mapping as a coordinate transform. And use the inverse Jacobian as the player's position to locally flatten. Godot shader implementation. So torus cores, oh yeah. So this inverse torus return T. Yeah, so I'm just getting... Well, I already have this function, right? I mean, but yeah, making a struct is not a bad idea. I like it. And it should be shorter, right? Maybe not. However, I noticed something which simplifies to this. So this alone does nothing. Oh, so the reason is that the Jacobian is only a linear approximation. Oh, applying Jacobian inverse and then immediately applying J cancels out exactly. What you actually want is... Okay. Then feed the flattened coordinates directly into the camera view transform. Let's convert them back with J. So from the player to the world position of the vertex. Yeah, you multiply by the check. Yeah, maybe. Then instead of letting Godot use the normal world position, we would construct a custom view space position from flat. Make nearby cubes looks undistorted. You have world position, subtract player, inverse Jacobian, view space, projection. Okay. Because that cancels out. Okay. 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 Can you show how you're currently modifying vertex? Are you modifying vertices before Godot's camera transform? Yeah. Overriding position. I'm using a base shadow as it is. Show me how to do that there, I guess. Optimizations could come later. Yep. For a local Euclidean correction, you need to bypass the normal transform and right position yourself. Local, okay. Okay. Convert the world space vertex into a displacement from the player. Yep, local. Apply the inverse Jacobian at the player's position. Okay. Treat that flattened displacement as if it were the actual world displacement. Transform directly into clip space. Do I really have to transform into clip space? What is that? Flatten. Oh, okay. Important caveat. Position. Only approximate the truth locally. If strongly curved. Nearby cubes looking good. Medium distance cubes skewing. And far cubes becoming wrong. Yeah, I know. For a voxel torus, a better solution is usually not Jacobian. Oh, okay. Yeah, I guess the Jacobian inverse is kind of that. Using the inverse torus coordinates for the near field correction. Mathematically elegant, but the exact inverse mapping usually produces the visual effect you're after. Yeah. I was thinking... Yeah, I'm glad I can think, I know. I'm gonna remove this again. So we have this. Yeah, I guess. I mean, I guess it's fine, right? So we have those. I like the mix, but yeah. Camera to vertex chunk space. Wait, I think I get it. What if I do the donut transform, but with different arguments? Um, but I think actually the problem, I think, is that I don't know what the problem is with this. Because both ways look the same. Looks good. Okay, it's there. There's some problem there. So it's kind of fine when I'm on the ground, but when I go up, it's starting to be just bad, right? Oh, because there's like the limit of the chunk, right? Oh! Oh yeah. Oh yeah. Oh yeah. I guess I have to wrap it, right? So like maybe I have vertices that are at the start of the chunk, but that should actually be like if the player is at the corner of a chunk, then you know it's repeating. So it should be kind of moving with it. Maybe that's the only problem. So we have all this. Chunk pose. So the vertex chunk pose. Yeah, this is maybe the problem. We need the size. Camera to vertex. We need to... Yep. Am I actually using it later on for something else? I'm not. Okay. Okay, this is interesting. Camera to vertex chunk pose. Okay, this is the interesting one. So we have this, but we should also have NB cubes. Right? Chunk size. Yeah, I mean chunk size is... Anyway. Yeah, flash free, vec free, NV cubes, let's say. Two, 3, 2, 5, and it should be good. And we're gonna do both. So vertex chunk pose 2. Cool. This. Then we have the same but with the minus. Just in case. And here we have, I mean basically the minimum. Wait, length. So it's the minimum Manhattan distance. Just like the mean between this and this. And then the same between this. And wait. I guess that's one min already done. And then the last min, which is with 3. And I just hope that min is, wait, what? Oh, right. Wait, what? Oh. Yeah, I mean like this. Okay, should be good. I hope. And yeah, I mean, let me just check, just in case, GLFL, mean on vectors. I think it's like the minimum components, right? Containing the smallest values. So 1, 2, 3, okay, this is good. And the one with the smallest components is obviously going to be the one with the size, well, with the minimum size. So it should be good. Hopefully. Oh, I forgot something. Did I? Let me think. NB cubes. Minus. Yeah, it looks fine. Okay, so when I go up this time, am I going to have a problem? And I'm not, apparently. Right now. Okay. I feel like I'm missing something, like I removed something I wrote, I don't know. It feels odd. It feels weird. And now when I dig... Yeah, no, it's not working. Hmm. Vertex world pause. Maybe here. Camera to vertex world space. This one is good. Thanks for the follow. Oh, Rapidi, hello! How are you? Been a while. How are you doing? Thanks for the raid. Go follow Rapidi. Wait. Ah. No. I was gonna raid you. Oh no. Bad timing. Bad timing. No raiding right now. Hails. A little shout out. Thanks a lot. Ravioli raid message. Alright. Then you, me, moi? Comment ça, moi? Wait, you? Oh, no, explosive. I guess you gotta keep going. I guess. I wasn't planning on stepping right now. I'm at an interesting part, and it's called morning. But aside from that, as you can see, I have like a donut. Let me get away. This is a big donut. And it's made of cubes. A lot of cubes. As you can see. That you can destroy because it's a voxel game, like Minecraft. And... and I was trying to do something, but it just didn't work. So I'm trying to make it work, obviously. I know, surprising. Let me show you what I was trying to do. I have like some crazy effects going on. I'm trying to make like some Nickelodeon stuff. Ho ho, mukatte kuru ka, Ravioli-chan. Kono frogs ni mukatte kuru ka. Dewa. Jubun shikazuku ga ii. Yeah, as you can see, I have like some transform here, right? So it feels always... So it always looks like a cube, right? It wasn't the case before. And... because... Drink. Thanks. So yeah, the problem with the donut... This sounds so bad. I'm gonna remove this. So wait, actually I can just remove this. The problem with donuts is when you dig. So like, you know, you have your donut, and when you dig down, it stops being a cube and it starts being like a quad, very thin, right? This is a problem. And I don't want that. because I want mines and stuff and, you know, fun, right? I want more space for the player to play, so I'm trying to cheat a little bit by creating space myself, out of nowhere, out of thin air, as you would say. So I'm trying to transform it. And as you can see now, we have... When we dig, it's always a cube. It's working, right? Maybe. What is that? But I don't know what this is. Oh, I guess it's like the limit. It's probably the limit. But yeah. It's getting really late for me. I'm getting a little hippie. Good night, everyone. Take care and have a great day. Yeah, thanks for joining and saying hi. I appreciate it a lot. Sleep well and see you end of the day. What am I gonna... Yeah. There's a problem with my current approach. Well, it's working well, though, right? But the problem is that when I continue, at one point it's becoming weird. There, right? Like it's the end of the world. Take care, the best wishes for you, Proxy. Thanks, you too. Yeah, we have some problem here. Like everything is just breaking. So I was trying to fix that. I don't know why there's this thing too there. Like, it's getting up, and this is getting down, and I don't know why. I really don't know why. Is it about the rotation? Do I have to rotate the... Wait, I'm just gonna continue. Okay, and yeah, now we have the problem again. We do? I don't know. Yeah, we do have something weird going on. What is that? Ah! Why is it going onto me? I don't know. I don't know. You... I don't know. So we have... Yeah, we're not using this. That's fine. The position of the camera in the chunk space, in the... Not the chunk, but like the donut space, I guess. We have the same for the vertex here. Vertex to respawn. Well, yeah, okay. We have all of this with smooth. And yeah, we have this. I shouldn't have to do this though, that's my problem. That's what I don't really like. So I'm not sure. So if I was... Okay. So yeah, it's a bit tricky. Oh, I didn't show you, but look at this, look at this. If I remove this, I wanted to show you. When I remove this, for whatever reason, I have this. I have the nut, and when I come closer, it's like turning around. So I really don't know why. There's like some distortion problem. Oh, maybe it's... Oh. Wait. Maybe it's linked to that. Maybe if I do minus... If I multiply by -1 for every coordinate, is it going to solve it magically? I don't know. So we have this. We stretch. Okay, I don't think it's working. Yeah, why is it stretching that way? See, what about X? I mean, I guess X was the problem actually, never mind. Just testing for science. Wait, what? That looks kind of sick. But not working. Oh, maybe it depends on... Oh, wait a second. I have to check something. I have to check if this is... So this is not working where I am, but is it working in other places? Is distorting? What if I go this way? Okay, so there's like the end of the donut. What about there? Distortion? Yeah. Yeah, okay. So first I have to fix the donut. I'm just gonna try my min thing again. Hopefully it works. So if I go there... Wait, let me check this again. No! So when I dig though... It's not working. Yeah, for some reason it just stops working. Like it's just the default thing now. Whenever I do this. I don't know why. Plus NB cubes. Oh, wait, oh, right, because it's always gonna be negative. Okay, yeah, that's kind of stupid. Got it. So, wait. NB cubes. I guess it's not really NB cubes. It has to do with like the size of the cubes, right? But I don't... Do I know it? I feel like I'm kind of close. I feel like this is the only problem. I have to close it, to close the world. Camera to vertex chunk space. Oh, and that's why sometimes it's not working too. Because if it's only like the vertex, then triangles are just going to be bad, to be like distorted like crazy. Okay, maybe I get it. I get it. And I don't know how to solve that. I mean, maybe with a geometry shader, right? That's like the only way. Let's go to support that. Go to geometry shader. No! Largely obsolete and inefficient. No! Mesh shaders and compute shaders. Yep. Runtime, vertex shaders. Maybe a compute shader then. Nope. Yeah, the problem is that even if I do a modulo with a vertex, the whole triangle is not going to get moduloed. Except if I... no, there's going to be some problems in any case. Actually, maybe not. No, that could be fine. And it's like a minus, it's not the distance. So just the mean doesn't... Okay, just the mean doesn't work, so let's do something about it first and think about more things later. So we have the position and we have the size, right? Actually, minus camera. Plus NB cubes minus NB cubes. I mean, this is kind of fine. Just that the minimum is always going to be, you know, this, right? Well, not really, actually. Well, anyways. Minus NB cubes. Yeah, no shot. Vertex chunk pairs minus camera chunk pairs. It's not the minimum coordinates, it's the minimum distance, right? So let's have something like this. Wait, distance? Um, Let me think. Ah, okay, it's actually a bit tricky. It's actually a bit tricky to compute it. Maybe I need some branches. Well, I mean, maybe, probably not. But for simplicity. Um, hmm. So yeah, there's definitely this minus. Minus n plus nb cubes. And I want to, based on conditions, pick coordinates. Vertex chunk pause. Yep. Yeah. I'm a bit too tired for that. So basically, sorry, I'm talking a lot to myself. What we have is voxel one. Voxel, right? So let's say this is our chunk, okay? Like a chunk. Maybe not, well, a place, right? The thing is, when you go here, you're supposed to get back here, right? So that means the closest path between here and here is this, basically. Instead of, actually, it's like this instead of this, right? So that's what I'm trying to do. I have to do that to handle that for x, y, z. And it's not like the minimum coordinates, because if I just do min, then obviously it's just going to be the one where I subtract things from. So yeah, I guess that's kind of the problem I have right now. Hmm. It's a very stupid problem, really, but yeah. My brain is a bit slow right now. Vertex chunk pause minus camera chunk pause. I mean, okay, let's do the easy thing, shall we? Camera to vertex chunk space. So let's say we have this, okay? I'm gonna do if Yep. Hmm. Let's actually do 1, 2, 3. Okay. What? Okay. Now I'm just gonna camera to vertex string space. I'm just gonna subtract. Boom. 2, 3. Camera chunk pause. Yeah, everything is good. And now okay. So I have to keep the coordinate negative, but I have to select it. Oh my god. I guess it's absolute actually. Right, it's a delta. I can try getting the modulo absolute. Maybe not modulo absolute. Yeah, just you know, modulo things. Yeah, but I just have so many coordinates. I want to automate it, but I feel like I can't really do that. That's why it's taking so long in my, well, from me. Expression vertex strength pass. What? Oh, right. It's like 1. Hmm. So when I do min, I obviously take the minimum. Hmm. Wait, camera chunk. Yeah, okay. Makes sense. Maybe it's fine. Min. Maybe I can just loop and do stuff. Yeah, maybe yeah, okay, let's probably do that. So let's say I have an array. Let's say I have vec3 of dimensions. Okay, let's do, yeah, okay, yeah, let's loop, let's definitely loop. Oop. What? Like this. Okay. So let's do for int I equals 0. How many coordinates do we have? 3, right? So you have to try all combinations. So it's Something like this. Well, should be good. I'm just gonna replace this by J. Okay. By habit, you could say. Vertex chunk pose. Okay, this is good. Maybe. So we have this. We have I. We have I. We have delta. Well, we have, I guess, this really. From camera to vertex chunk space. Is it? Is it actually? Yeah, it is. No, it's not. A to B minus A. Yeah, okay, no, that's fine, that's fine. So I have this thing. And at the end, we are going to have... It's gonna comment this, I guess. Just gonna have this be yeah, J equal min value equals something like crazy, I guess. I assign it, and if this is less than min value, then min value equals this. Oh, GD script. So then we have the min value every time, but it's not how it's supposed to be because it's like the same as before right now. So I just have to ensure that this plus MB cubes, and it's like modulo, so like mod f, mod. What's the difference? Anyway, mod f. I just have to ensure that this is less than the minimum value. 1, 2, 3. Wait, what did I miss? Nothing, right? Oh, it's modulo. Yeah, no, it's right, like this. Invalid arguments, vec free and float. Oh no. Yes. Mod f is nothing. Is it? What about mod? GLSL mod. It's supposed to be good. Let's try. Let's see how it goes actually. Actually, camera, yeah, should be good. Should be straightforward. I might be forgetting something, but yeah. No, it's definitely bad. Okay, I'm starting to fall asleep, so I'll probably be going myself. Woo. Ah. Well, thanks for watching. I'm gonna raid. Games that Metroidvania month. Oh. Access a witch. What is that? Micro Jam? I don't know this one. Any?
Okay. Very mad.
Oh. Some ad, I'm sorry about this. How can I mute? Perfect. So yeah, that's gonna be it. Thanks y'all. Thanks y'all a lot. Sorry, I wish I could continue, but my eyes are just shutting down. And I feel like it's not really productive to continue at this rate. Maybe I'm going to have like some really good idea to solve everything next time. I mean, I was basically doing something that was supposed to work, but I don't know. It's not working. Wait a second, it's not really what I was doing though. Was it? Wait. Yeah, I guess I'm going to think about it a bit more another time. Camera to vertex. Yeah, anyways. Thanks for watching. Bye bye. And have a nice day.